Hey everyone, welcome back. Today, we're going to dive into one of the absolute slickest tricks in the world of algorithms, the sliding window technique. And we're not going to write a single line of code, I promise. We're focusing purely on the logic, the kind of thinking that just makes everything click. So, have you ever been staring at an array problem and just thought, how in the world am I supposed to check every single little chunk of this thing? The obvious way, checking every possible combination one by one, what we call the brute force method, is a total nightmare. It's slow, it's messy, but what if I told you there's a way smarter way to do it? So, to really get this to click, we're going to use a simple and, frankly, pretty delicious analogy, the buffet line. Okay, picture this. You're at a buffet, and your tray can hold exactly 3 plates. You want to find the best possible 3-plate combination. Now, instead of picking up your tray a million times to try every combo, what do? You just slide it down the line, right? You grab your first 3 items, check them out, then to see the next group, you just drop the first plate off the back as you add a new one to the front. That's literally it. In our world, the buffet line is your array, and your tray is the window. Okay, let's make this real with an example. Let's say we have this array of numbers. Our tray, or our window, starts by holding the first 3, 2, 1, and 5. If we add those up, we get a total of 8. Simple enough, right? Okay, now here's where the magic happens, the slide. To check the next set, we don't start all over from scratch. No way. All we do is subtract the number we're leaving behind, that 2 at the beginning, and add the new number we're scooping up, which is the 1 on the right. Our new window is now 1, 5, 1, and our new sum is 7. See what we did there? We didn't have to re-add everything. That is the secret sauce. That's the efficiency. All right, so that's the big idea. Now let's pop the hood and look at the actual mechanics. How does this sliding really work? Well, it all boils down to managing the start and the end of our window. And we do that with 2 little markers, or pointers. You can think of it like a 4-step dance. Step 1, we expand. A right pointer moves forward, making our window bigger. Step 2, we check. Is our window doing what we want it to do? Does it meet the condition? Step 3, we shrink. If the condition is broken, a left pointer moves in from the other side to shrink the window. And step 4, you guessed it, repeat. It's just this constant little rhythm. Expand, check, shrink, repeat. And this right here is why we care so much. On the left, that brute force approach is like trying to untangle a giant knot. For a list with n items, it can take n² steps. And trust me, that gets slow, like go make a coffee and come back slow. But the sliding window on the right, it's like taking a clean walk down a straight path. Just one pass. We call that O of n. This isn't just a tiny improvement, it's the difference between a program that finishes in seconds and one that could literally take hours. Okay, but here's the thing. This technique isn't a one-trick pony. It actually comes in 2 main flavors, and which one you use depends entirely on the problem you're trying to solve: fixed size and variable size windows. And this table breaks it down perfectly. Just look at the goal. A fixed size window is when you need to find something in a chunk of an exact size, like our 3-plate buffet tray. But a variable size window is for finding the longest or shortest chunk that meets some kind of rule. Because of that, the movement's different. In a fixed window, the pointers move together in lockstep, but in a variable one, the right pointer expands and the left one only shrinks when it has to. The analogy says it all. One tray always holds 3 plates, the other can grow or shrink whenever it needs to. All right, let's zoom in on that first flavor, the fixed size window. The key word here is fixed. Your window is set in stone. It never, ever changes size. So let's apply this. Imagine we're a manager, and we want to find our company's best 3-day sales streak. Well, we'd start our window on the first 3 days. The sales are 10, 20, and 5. That gives us a starting total of 35. Then we slide. We drop that first day's sale of 10, and we add the next day's sale of 30. Our new total jumps up to 55. And since 55 is better than our old total of 35, we update our record for the best so far. And you just keep doing that. Slide, update, compare, all the way to the end of the list. All right, now for the second, more dynamic flavor, the variable size window. This is where things get really flexible. We're not locked into a specific size anymore. The window adapts to whatever the data throws at it. So let's tackle a new problem, finding the longest streak of positive numbers in a row. We start at the beginning. We see a 1. Hey, that's positive, so our window is just that one number. Current streak, 1. Easy. Okay, so our right pointer moves on. And, oh, it hits a -2. Bummer. That breaks our all-positive rule. So what happens? The window has to reset. We jump our starting point past that bad number, and we start fresh with the 3. From there, the window expands again to include the 4, giving us a new streak of 2. Since 2 is bigger than our old max of 1, we update our record. The key thing to remember is that the window grows as long as things are good, and it shrinks or resets the moment a condition is broken. Okay, so you've got the logic down, you've seen the 2 flavors, but the million-dollar question is, when do you actually use this thing? Let's go through a quick little field guide to help you spot these problems in the wild. Be on the lookout for these keywords in a problem description. If you see subarray, substring, or anything about consecutive elements, ding ding ding, your sliding window alarm should be going off. Same goes for problems asking you to find a max or min sum within a range, or the longest or shortest something that fits a certain rule. And while you're at it, please try to avoid these common pitfalls. I see them all the time. First, it is so easy to do all the work of shrinking the window and then just forget to update your answer. And the other big one is just mixing up your window types. Make sure you know right away if you need a fixed tray or a stretchy one. Getting that wrong from the start can cause a lot of headaches. So if you remember anything from all this, remember this. The entire technique, the whole shebang, just boils down to this simple forward mantra. Expand, check, shrink, repeat. It really isn't magic. It's just a wonderfully smart and efficient way to think about problems. And there you have it, the sliding window technique in a nutshell. So I'll leave you with this final thought. Beyond all the algorithms and code, where else could this logic of a sliding window of focus apply in your life? Maybe in how you manage your weekly to-do list, or how you look at trends over time. It's a really powerful pattern for thinking. Thanks for watching.